Have you ever wondered what would happen if a comet was on a collision course with Earth? Today, we'll explore the fascinating world of comets, focusing on the enigmatic Comet Encke and its potential impact on our planet. Amidst so many theories and speculations, it is easy to get lost in myths and misinformation. But what does science really tell us about these celestial bodies? In this video, we will demystify apocalyptic scenarios and bring to light the scientific facts about comets and their true risks. If you are passionate about astronomy and want to understand how these natural phenomena can influence our future, stay with us until the end. Discover how scientific knowledge can not only satisfy your curiosity but also prepare you to separate fact from fiction. Comet Encke, named after the German astronomer Johann Franz Encke who calculated its orbit in the early 19th century, is one of the most intriguing celestial objects we observe today. First discovered in 1786 by Pierre Méchain, Encke has fascinated astronomers for centuries due to its remarkably short orbital period of just over 3 years, making it the comet with the shortest known period in our solar system. This frequent return to the inner solar system offers scientists a unique opportunity to study its characteristics and behavior over time. Physically, Comet Encke is a typical comet composed of ice, dust, and rocky material. Its nucleus measures approximately 4.8 kilometers in diameter, which is relatively small compared to other known comets. Despite its size, Encke's frequent visits to the inner solar system have led to significant erosion of its surface, resulting in a trail of debris that contributes to the Taurid meteor showers observed annually on Earth. The orbit of Comet Encke is particularly noteworthy. Unlike many comets that originate from the distant Oort cloud, Encke is believed to have originated from the Kuiper belt, a region of the solar system beyond Neptune filled with icy bodies. Its orbit is highly elliptical, bringing it close to the Sun and then swinging it out past the orbit of Mars. This trajectory not only makes Encke a subject of interest for astronomers but also raises questions about its long-term stability and potential interactions with other celestial bodies. Scientifically, Comet Encke is significant for several reasons. Its short period allows for repeated observations, helping scientists understand the processes that govern cometary evolution and behavior. By studying Encke, researchers can gain insights into the history of the solar system, as comets are considered to be remnants from its formation. Furthermore, Encke's interactions with the solar wind and gravitational forces provide valuable data on how these factors influence cometary paths and activity. In conclusion, Comet Encke serves as a window into the past and present dynamics of our solar system. Its frequent appearances and unique characteristics make it a rich subject for scientific inquiry, offering clues about the origins of comets and their roles within the cosmic theater. As we continue to observe Encke, we deepen our understanding not only of this particular comet but also of the broader mechanisms that shape our celestial neighborhood. Comets have long captured human imagination, often shrouded in mystery and myth. Throughout history, they have been seen as omens of doom or harbingers of significant change. The Comet Encke, like many others, is no stranger to these myths. One prevalent myth is that comets, including Encke, pose an immediate and catastrophic threat to Earth. This perception is often fueled by sensationalist media and movies that depict dramatic collision scenarios, leading to widespread public anxiety. However, the reality is quite different. While comets do represent a potential impact risk, the probability of a catastrophic collision with Earth is extremely low. The trajectory of Comet Encke, for instance, is well documented and closely monitored by astronomers using advanced technology. This allows scientists to predict its path with high precision, significantly reducing the likelihood of unexpected impacts. In fact, Encke's orbit is such that it poses no immediate threat to our planet, as it passes at a safe distance during its perihelion. Another common myth is that comets are unpredictable and can change their orbits suddenly, increasing the risk of collision. While it's true that comets can be influenced by gravitational forces and solar radiation, these changes are typically gradual and can be anticipated by scientists. The use of sophisticated models and simulations enables astronomers to project potential orbital shifts and adjust their predictions accordingly. This proactive approach ensures that any potential risks are identified well in advance. Furthermore, the idea that comets are harbingers of disaster has no scientific basis. Historically, comets have been associated with natural disasters or societal upheaval, but these events are coincidental rather than causal. Comets, including Encke, are natural phenomena that follow predictable paths governed by the laws of physics. Understanding these paths helps dispel the myths and focus on the scientific facts. The real risks associated with comets are not from direct impacts but from the debris they leave behind. Comet Encke, for example, is responsible for the Taurid meteor showers, which occur when Earth passes through its trail of dust and debris. While these meteor showers are mostly harmless, they can occasionally produce larger meteoroids that pose a risk to satellites and, in rare cases, the Earth's surface. By focusing on scientific facts, we can better understand the true nature of comets and the risks they pose. The study of Comet Encke and others like it provides valuable insights into the dynamics of our solar system and the processes that govern cometary behavior. Through continued observation and research, scientists aim to further demystify these celestial bodies, ensuring that our understanding is based on evidence rather than myth. In summary, while comets have been the subject of many myths, the scientific reality is far less dramatic. Comet Encke, with its well-documented orbit and predictable behavior, exemplifies how scientific inquiry can dispel fear and misinformation. By embracing a fact-based perspective, we can appreciate comets for what they truly are, fascinating remnants of our solar system's formation, rather than harbingers of doom. Monitoring comets like Encke is a complex task that relies on a combination of advanced technology and collaborative efforts across the global scientific community. The process begins with telescopic observations, where astronomers use powerful ground-based and space telescopes to track the position and movement of comets. These observations are crucial for determining the comet's orbit, speed, and trajectory, providing the foundational data needed for further analysis. One of the primary tools used in monitoring comets is the Near-Earth Object (NEO) tracking system, which is part of an international effort to identify and catalog celestial bodies that come close to Earth. This system uses a network of telescopes and radar facilities to continuously scan the skies, updating databases with the latest information on known comets and asteroids. For Comet Encke, this means its orbit is regularly updated, allowing scientists to predict its future positions with great accuracy. In addition to telescopic observations, radar technology plays a vital role in monitoring comets. Radar systems can bounce signals off a comet's surface, providing detailed information about its size, shape, and surface properties. This data is invaluable for understanding the physical characteristics of comets and assessing any potential impact risks. For instance, radar observations can help determine whether a comet's nucleus is solid or fragmented, which can influence its behavior as it approaches the Sun. The data collected from these observations are fed into sophisticated computer models that simulate the comet's orbit and predict its future path. These models take into account various factors, such as gravitational influences from other celestial bodies and the effects of solar radiation. By simulating different scenarios, scientists can anticipate changes in the comet's trajectory and assess the likelihood of any potential impacts with Earth. Collaboration is key in the field of comet monitoring. Organizations such as NASA, the European Space Agency, ESA, and other international bodies work together to share data and resources. This collaborative approach ensures that the most accurate and up-to-date information is available to researchers worldwide, enhancing our ability to monitor and understand comets like Encke. One notable example of successful comet monitoring is the Rosetta mission, which provided unprecedented insights into cometary behavior and composition. Although Rosetta did not study Encke specifically, its findings have informed the broader field of comet research, helping scientists refine their models and improve prediction accuracy. In conclusion, the monitoring of comets is a testament to the power of scientific collaboration and technological innovation. By leveraging a range of tools and techniques, scientists can effectively track and predict the movements of comets like Encke, ensuring that we remain informed and prepared. This proactive approach not only enhances our understanding of these celestial travelers but also underscores the importance of science in safeguarding our planet. The potential impact of a comet like Encke, while statistically unlikely, is a scenario that scientists take seriously. Understanding these potential impacts involves assessing both the immediate and long-term consequences of a comet's collision with Earth. In this chapter, we explore the possible scenarios and the preparations in place to mitigate such risks. In a hypothetical impact scenario, a comet's collision with Earth could release an immense amount of energy, equivalent to thousands of nuclear bombs. This could result in significant destruction, depending on the size and speed of the comet. The immediate effects would include shockwaves, intense heat, and widespread fires, potentially leading to devastating loss of life and infrastructure. Longer-term consequences might involve climate disruptions, such as a nuclear winter effect, where debris thrown into the atmosphere blocks sunlight, leading to global cooling and agricultural collapse. Given these potential outcomes, it's crucial to have effective preparation and response strategies. One of the primary methods of preparation is the ongoing monitoring and tracking of comets, as detailed in the previous chapter. By predicting a comet's trajectory well in advance, scientists can provide early warnings and allow for timely evacuation and other protective measures. International collaboration plays a pivotal role in preparing for potential comet impacts. Organizations like the United Nations Office for Outer Space Affairs, UNOSA, work with national space agencies to develop coordinated response plans. These plans include strategies for deflecting or disrupting a comet's path, should it pose a direct threat to Earth. Techniques under consideration involve using spacecraft to alter the comet's trajectory through kinetic impact or gravitational pull, effectively nudging it off course. Public education and awareness are also vital components of preparation. By informing the public about the real risks and the measures in place to address them, authorities can reduce panic and ensure that people are ready to follow instructions in the event of an emergency. Educational campaigns can help demystify comets and highlight the scientific efforts aimed at protecting our planet. On a more practical level, governments and local authorities conduct regular drills and simulations to test their readiness for various disaster scenarios, including comet impacts. These exercises help identify potential weaknesses in response plans and ensure that emergency services are well prepared to act quickly and effectively. In summary, while the likelihood of a catastrophic comet impact is low, the potential consequences are significant enough to warrant careful preparation and planning. Through international cooperation, scientific innovation, and public education, we can mitigate the risks and ensure that we are ready to respond to any threat. The study of comets like Encke not only enhances our understanding of these celestial bodies but also strengthens our ability to protect our planet from cosmic hazards. As we reach the end of our exploration of Comet Encke and its potential impact on Earth, it's clear that understanding these celestial phenomena is crucial for both scientific advancement and planetary safety. Throughout this video, we've delved into the fascinating history and characteristics of Encke, debunked common myths surrounding comet impacts, and examined the sophisticated methods used by scientists to monitor and predict cometary behavior. The insights gained from studying Comet Encke underscore the importance of scientific inquiry in demystifying the universe. By separating fact from fiction, we not only alleviate unnecessary fears but also foster a deeper appreciation for the intricate dynamics of our solar system. The knowledge that comets like Encke are closely monitored and pose no immediate threat to Earth should provide reassurance and inspire confidence in the capabilities of modern science. Moreover, the collaborative efforts in comet monitoring and impact preparedness highlight the power of international cooperation in addressing global challenges. As we continue to refine our understanding and response strategies, we enhance our ability to safeguard our planet from potential cosmic threats. In closing, we encourage you to remain curious and informed about the wonders of the universe. By engaging with scientific content and questioning sensationalist narratives, you contribute to a more rational and enlightened society. We hope this video has enriched your understanding of comets and inspired you to explore further into the vast cosmos. Thank you for joining us on this cosmic journey. Remember, the universe is full of mysteries waiting to be uncovered, and each discovery brings us closer to understanding our place in the cosmos. Stay curious, stay informed, and keep looking up. As we wrap up this exploration of Comet Encke, we extend our gratitude to all those who have contributed to our understanding of this fascinating celestial body. From the pioneering astronomers of the past to the dedicated scientists and researchers of today, their collective efforts have illuminated the mysteries of comets and enriched our knowledge of the cosmos. We'd like to thank the various space agencies and observatories worldwide that provide the data and resources necessary for comet monitoring and research. Organizations like NASA, the European Space Agency, ESA, and numerous international partners play a vital role in advancing our understanding of comets and ensuring our preparedness for potential impacts. For those eager to delve deeper into the subject, we recommend exploring additional resources and readings. Websites of major space agencies often feature detailed articles and updates on comet research and missions. Additionally, consider visiting online platforms such as the Planetary Society, which provide accessible insights into the latest developments in space exploration. We also encourage you to check out documentaries and educational videos available on streaming platforms, which offer visual and engaging explorations of comets and other celestial phenomena. Books by renowned astronomers and scientists can provide further context and depth, offering both historical perspectives and cutting-edge research findings. Finally, we invite you to join online communities and forums dedicated to astronomy and space science. Engaging with fellow enthusiasts and experts can enhance your understanding and provide opportunities to discuss and share insights about the universe. Thank you for watching and for your interest in the wonders of space. As we continue to explore the cosmos, remember that every discovery brings us one step closer to understanding the intricate tapestry of the universe. Keep exploring, stay curious, and never stop learning.